Hey everybody, today I'm going to find a derivative using implicit differentiation, and I have two examples right here that tell us the difference between an explicit equation and an implicit equation. X times y equal x squared is implicit because I have x and y in this side of the equation, on the left side of the equation, right? And I got x squared on the other side, but I have x and y in the left side of the equation. Explicit, y equal x squared, okay? So to find the derivative of y equal x squared, okay, is dy dx equal to x, right? That is explicit. Now, I'm going to use the implicit differentiation to find the derivative of this equation right here is x cubed minus xy plus y squared equals 7. I'm going to take the derivative of every single term with respect to x and multiply the derivative of y by dy dx, right? So I'm going to rewrite everything with taking the derivative of with respect to x, which it will be d dx x cubed minus d dx xy plus d dx y squared equal d dx of 7. Okay, now that I have this, I'm going to take the derivative with respect to x. And I'm going to take the derivative with respect to y, but also at the same time take the derivative with respect to x on y. Alright, so the derivative of x cubed is 3x squared, right? The derivative, this is the product rule, right? So I'm going to take the derivative of x. Well, the derivative of x with this, right? So they match each other, so I have to just put 1, right? Multiply y, right? It's the product rule. And then I gotta do plus, right? The derivative of y, but remember that this piece right here is attached to it, so x is negative, right? So I have to multiply by a negative x, right? And if I take the derivative of y is 1, so 1 times dy dx. Okay, so one times y, right? The derivative of y is 1 multiplied by dy dx. Because we took the derivative with respect to y, we have to multiply by dy dx. Plus the derivative of y squared is 2y multiplied by dy dx again. So 2y times dy dx. The derivative of 7 is just 0. Right? Now I'm going to simplify this. Alright, so in this side right here I got 3x squared minus y minus x. Alright? And remember I'm multiplying dy dx, so this is x dy dx plus 2y dy dx equals 0. Now I am going to move whatever doesn't have the y dx to the other side. Well, this piece right here doesn't have the y dx, so I have to subtract 3x squared and minus y. I have to move to the other side. So I get minus 3x squared, and I have to add y, so it's plus y in this side, right? So I will have x dy dx equal, plus 2y dy dx equal negative x squared plus y. Okay, now I gotta factor out dy dx out. Okay, when I factor out dy dx, this is going to be equal, right? I'm going to write everything right here. And this is going to be dy dx, leaving negative x plus 2y equal negative 3x squared plus y, right? On the other side. Now, I gotta divide by, in order to solve for dy dx, I need to divide by negative x plus 2y, right? So divide by negative x plus 2y, negative x plus 2y. This cancels out, and I get dy dx equals 3x squared plus y over negative x plus 2y, right? Now this whole piece can be rewritten as, if I treat this piece, right, I can just switch them out, right? And I can say, okay, I'm going to just switch them out to get, I don't like the negatives over here, so all I can do is just switch them around and get the y in the front, right? So this whole thing can be rewritten as y minus 3x squared over 2y minus x. Okay, that will be the answer for that. It's pretty. It's not too bad. It just requires a little algebra because you have to divide by whatever you got. You have to solve for dy dx, so you have to divide by. In this case, we had to divide by this negative x plus 2y on both sides. So it's not really bad. All right. So this is the final answer for this. Dy dx equal y minus 3x squared over 2y minus x. That would be the implicit differentiation for this equation right here. Thank you for watching. I hope this helped.